Hi, in this session we're going to have a quick look at the ARMS Data Viewer client. And this is actually an auxiliary client just to view risk factors that are used in the value risk calculations and evaluations in ARMS. And one of the main reasons why you might have a large VAR number or evaluations that don't add up to the expectations is obviously if your market data is incorrect or faulty, or you have spikes in the data for some reason. So let's have a look. We start with the data viewer client, and we go to the first tab, the series tab, and we can now see that we have some choices. We can either choose to filter the risk factors on a specific portfolio for a specific day, which means that we will only view the risk factors belonging to a certain portfolio. The superset of risk factors in ARMS might be much larger, obviously, but you can also then view this without the portfolio, and then you see all the risk factors that are loaded. Then it might be convenient to filter on a factor type. So we can see all of them, FX, yields, equity, spread, volatility, and credit spreads. So let's take a look at FX sorted by standard deviation. And this is what we have here. So we can see that red is now 2.3, more than 2.33 standard deviations, which would be the equivalent of a one-sided 99% confidence interval. So this means that this move is larger than 1 in 100 days on average. And we can see that we're only calculating the average using the last 30 days. So if we use the last 100 days, it's no longer a 2 standard deviation move, it's less. So, and then we can view something else. We could look at our equity risk factors and see how these are doing. And here we can see that we're missing quotes. So this is probably, and we see the status with the whole. So here is something wrong, or someone has not cleaned the import of the database. So this is a good start to search for risk factors. If we then run with use portfolio, we can show all, and then we get all the active risk factors. And again, we can see that, well, we have a couple of ones that have large moves, but we can see that this is the Eonia spread to the swap spread that makes a big move, but in very, very small absolutes. So let's go on. Let's look at the next tab. So here we can look at individual risk factors. So we can then filter and find, for instance, an equity time series. And then in order to get a description, we can add the descriptions, and then we can now see and search for a specific time series to look at. We can look at some bank stock, for instance. So we see the history, we see the quote itself, and we see the actual quotes in this view. And we can change the number of days we look at to view 500 days, and then we get a longer history. Then we can move on, and we can look at the curves going into the system. And we have 2 curves to compare. So we can look at the swap curve, for instance, and we can then at the lower look at some sort of corporate spread or municipal spread. So we can see then that we have more or less perfectly smooth the current values and yesterday's values from date and date previous. So if we take the difference, the 10-day difference, we get a larger move. Well, not in swap curve. Let's take a 20-day difference then and see if we get a big move. Well, now it moves anyway, so the rates have gone down. And these corporate bonds spreads have moved as well. And then we move on to correlations. So if you would run a var with correlations implied into them, so the delta, delta gamma, or the Monte Carlo simulation, then you might want to see what kind of correlations that would be proposed. And again, you have the option to use the portfolio, which is nice because the correlation matrix will become very large otherwise. And then filter, so we can see now all the yields that are active in our portfolio, and then we get a correlation matrix symmetrical with all risk factors versus all risk factors. And we can show all again, and so we get here vol surface nodes and how they correlate to the actual underlying, for instance. And we can see how the vol surface nodes correlate with each other. Close nodes are obviously very close in correlation. And then last, we have the surface model. Since ARMS uses volatility surfaces as risk factors, we can then choose a surface to view. So we get all the surfaces, and then we can ask for a view of these surfaces. So we get all the nodes, and we get we get a smile for each maturity, and we get for each moneyness we get a time decay. So here we can see the term structure for a given moneyness, and we can also see the smile. And here we can also see our volatility surface in 3D. So and then we can switch between different maturities. So this would be the 3-month maturity, and this would be the time decay for moneyness just out to the money, 105 moneyness. And this is a very good way on understanding why risk is higher or lower than expected, and should be used before doing any serious analysis of VAR calculations in the rest of ARMS. Thank you very much.